Hello, good afternoon. Can you hear me? Anyone please confirm? Can you hear me?
Yes, sir.
Okay, nice. Okay, so welcome to the second lecture of CS 204 Computer Architecture. So from this lecture, we'll start the actual content of this course. The first lecture was only for explaining the details about the course, marking scheme and all. But you have to remember that the whatever I've explained in last first lecture is very important. And the PDF file is also shared with you. So you please read the PDF file once and try to understand all the rules that I have mentioned there. Those will be strictly followed throughout the semester. Okay, so let us start today's class. But before starting today's class, I'm reminding you that please download the textbook or collect a copy of this textbook. There are three options. Either you can collect a copy from library, or you download. I think older versions PDF will be available in internet. You can download it, or you can purchase also a fresh copy. So, but you have to collect a textbook as early as possible, because you have to read the book. Just my lecture is not enough. I'm reminding you again. Maybe I'll not repeat it every time, but you have to understand that after completing my lectures, you have to go and read those specific section from the book. Then only everything will be clear. I hope you will follow this. Okay, but today's lecture is not directly depend on your textbook, because whatever I'll explain today is not exactly from textbook. For that's why it is not necessary that whatever I'll discuss today, that you need to read the exact same topic from book. You may not find it also. So what I am doing today is I'm explaining you how computer works and what are the internal mechanism of computer in a less technical manner. Less technical means why it is completely non-technical, because it's not possible to explain everything in non-technical way. That's why I have written here less technical. So I'll try to explain how computer works, what are the internal mechanism of computer today in a less technical manner, so that everyone can understand it. Okay, so let us start the discussion. I'll start with history of computer. So from which point the concept of computer comes. So the history of computer starts with this person. Can anyone, do you know who is this person? Alan Turing. Yes, he is Alan Turing. So I hope you know that there is a Hollywood movie also based on his life, Alan Turing. So in 1936, yes, Enigma. Enigma is the name of the movie. So in 1936, this Alan Turing has proposed a machine. So it's not a physical machine; it's a theoretical machine. Means it's a concept of machine proposed in pen and paper. It's never designed in a physical manner. So it's a theoretical machine he proposed in 1966. Oh, sorry, yeah, the movie name is different. Anyway, you can search it. Yeah. So what I was saying, that he proposed in 1936, he proposed a theoretical machine, and that in that machine he mentioned that there will be a tape like this. This you can see there is a tape. So don't think that this the diagram here is the actual machine. This is just a representation of the whatever the theoretical machine that he has proposed. So it was never designed as a physical machine. So don't think that any real picture will be exist. So assume that there will be a tape like this, and in this tape you can write something, and you can also read from something from this tape. And for reading and writing, there is a mechanism here. Suppose and there is a head here. This is called head. So this head can read something from this tape, and then after reading the head can either move in left direction or right direction, and it can also write something on this tape. And the tape is of infinite length. Suppose. So I'll not go in more detail about this Turing machine, but with this Turing machine, with this machine, he proved that whatever algorithm or whatever problem that a human can solve, the same problem or same algorithm can be solved by this machine also. that he proved on 1936, and that machine is called Universal Turing Machine, UTM. So those who are from CSE here, computer science and engineering, so you will there will be a separate course for you to understand the concept of Turing machine and all, because without that your course is not complete. But for other those who are from other stream, these things may not discuss to you, but for you it may not be very important. For you, if you from this course, if you only understand how a computer works, it will be enough. But since the beginning of computer is from this Universal Turing machine, so that's why I'm explaining it here in short. Computer science people, you will have a complete course on it, on this type of concept like Turing machine and all. So I hope you're understanding the main concept here, that I'm saying that in Turing machine there is a tape which you may also call as memory. These you can also call as memory. This tape, but in Turing machine it's named as tape. But there is a head here. This head is you can read something, or and it can also move left and right, and it can write also some left and right, and it can also write something to this tape. Okay. So this model was proposed in 1936, and again I have said that this is a theoretical model. But after almost 10 years of this model, and I think on 1945 or 1946, this model has been proposed. This model is called von Neumann architecture. And even today, almost all the computer, laptop, server machine, or even mobile phone that you are using, almost all of them follow von Neumann architecture. So the computer, how computer works, in short, they follow von Neumann architecture. Now, let me explain you what is von Neumann architecture. You can see from this von Neumann architecture, there are three major components here, four major components in fact. One is central processing unit. This is one component. Another component here is memory unit, and then third component is input device and output device. So how this von Neumann architecture proposed? Again, it was also a theoretical model. When it was proposed in 1946, then at that time it was also a theoretical model. So what this model says is, initially your every data will be stored in memory, and whenever you want to do something with those data, then those data will be fetched from memory to central processing unit. Suppose your all data are initially stored in memory, and whenever you want to do something with those data, then those data will be fetched from memory to central processing unit, and then the central processing unit will perform some operation on your data, and after this the final result will be again written back from central processing unit to memory. So this is how a von Neumann architecture was defined, that initially your every data is in memory. One by one, if you want to do something on those data, you have to fetch the data into the central processing unit, and central processing unit will perform all type of operations. Okay, now let us relate it with the real life example here. How I am saying that almost all the modern computers or computers follow the same von Neumann architecture. For example, suppose you're in your laptop, you have two video files. Okay, and now you want to merge those video file and make a third video file. So you can always download a video file merger software from internet, right? And suppose you have a software installed in your machine who can merge two video file. So what you will do, you cannot realize that what is happening inside, right? So you will just open the software, you will select these two video file, and then you'll click the merge button, and then it will be merged. But what actually internally is happening, your initial two video files are also stored in memory, because your computer will not run if there is no memory. At this moment, you can assume memory means hard disk. I'll go more about other memories also, but assume that initially your data are in hard disk. I hope everyone knows what is called hard disk here. So initially your both movie clips are in hard disk, and if you want to merge this, then one by one both the movie will be the entire movie clip will be moved from your memory to central processing unit, and then central processing unit will perform the merging operation, and one by one the result will be written back to the memory, so that the final result, the merged file, can also store in the memory. So this is an example. So almost every operation that you are doing, your data initially stored in hard disk, right? Because suppose I'm running a laptop here now, if I shut down this laptop, every data will be in the hard disk, and when I'll restart the computer again, then data will be moved from hard disk and then if any processing is needed, then the data will be moved from hard disk to the processor. I am ignoring some other memory devices here, but I'll explain it later to you. I hope you are understanding how the von Neumann architecture is relating to our modern devices. An input device and output device is well known to us. So now, at this moment, can we relate this diagram with some real life example? Like, can you give some example of central processing unit? Any central processing unit means processor of modern computer. So maybe I can write Intel i7, right? Or Intel i5. Normally, when we try to purchase a laptop from Amazon or Flipkart, what we search? First we search the processor, right? It is Intel i7 or not, it is Intel i5 or not, how many cores are there. Everything will be discussed in this course, but not today. Today you just I'm just giving few names. So these Intel i7 or Intel i5 are the name of some processors. Okay. And memory unit. Memory unit, we know hard disk is a memory unit, right? So hard disk, normally we say HDD, and then RAM. RAM is well known, right? Everyone will know. Even when we go for purchasing a mobile phone, we normally search how much RAM is there, whether the RAM is 3 GB RAM or 4 GB RAM. So RAM is well known. We know what is RAM, and I think those who are using a computer also know what is called hard disk. And maybe we also whoever using memory or using mobile phone also know the term called what's called memory card. So you can also consider memory card as kind of hard disk. Pen drive, we all know, right? Okay, just 1 minute. Hello. हाँ शीतल. हाँ हाँ. अब उसको फोन नंबर तो कार्ड मेल कर दिया मैंने, और मैं अभी क्लास में हूँ बोल रहा. हाँ हाँ. Okay. Sorry. So, okay. So, and what are some example of input device? Input device we can consider as keyboard is the input device, right? Keyboard is the input device. Output device, monitor is the output device. Okay. So now, how we use a computer. This is how we use a computer. So to use a computer, normally we give some command. Computer has no brain. Normally people think like this: the computer is a very smart device. It can act as a human and all. It's not true. Computer is also a brainless device. Just like a JCB, like we all know that is how a JCB dig earth, right? Suppose if a JCB is digging earth, so it will collect some mud, and it will put it in the truck. So you can see there will be some sequence of commands, right? But it's not it doesn't have any brain, right? Someone is instructing, a driver is inside the JCB, he is giving some sequence of instruction, then move right, collect earth, then move up, then put it in the truck, right? So one way there will be some sequence of instructions. So those sequence of instructions are very important. So the same thing is true here also in computer. So when we run a command in computer, so when you run a program, suppose if you want to run a program like this, I hope you understand what is called program, because you have already taken a course of programming, right? G103 is already done. So suppose you have written a C program like this, and if you want to run it, then first you will compile it, and after compiling, when you will execute, the program will execute. I'll explain this internal step later, but at least you know how to run a program. So but when you are writing a program, what actually you are writing? You are actually writing a sequence of command. You are giving a sequence of command to the computer, and computer will exactly behave as you are giving the commands to this computer. Okay, so I think you can relate this example, the example that I have given with of a JCP here. This exactly, it's kind of similar thing here. Also you have to give sequence of command. If you are not giving any command, your computer cannot do anything. That's why I'm saying it has no brain. Okay, so now in this entire course we'll understand two concepts. First, how to write those commands. This is very important. And once you write this command, then the next 2 points are where the command will be initially stored. Initially the command will be stored in memory, and as I said, according to von Neumann architecture, if you want to do something, then those commands will be fetched from memory to the central processing unit. So how the central processing unit works, how this central processing unit will execute your command, because you are giving a command to the computer, fine, but how the command is executing in central processing unit, this is one major part of this course. And the second part is how you are storing those program or those data in the memory. This is the second part of this course. So mainly these two parts will be discussed in this course. So now maybe you can start with memory. So I think in non-technical way, we know what is called memory. If I give you a what you call memory card, or if I give you a pen drive, you know what is stored in pen drive. Or suppose if I consider only pen drive, then you know that a movie can be stored in pen drive, a file can be stored in pen drive, or if you have written a C program, that program can be also stored in your pen drive, right? But the structure of data is different, right? If you are storing a file like C program in a pen drive, then when you open it, you will see some lines written in English, right? But if you store a MP3 file, if you click it, then it will play a music. If you store a video file in the pen drive, and if you open it, then it will play a video, right? But the things, the actual concept here in memory is how you are storing those data. Do you think that the storing mechanism of video file, storing mechanism of MP3 file, and the storing mechanism of a program file is different in memory? Actually, the internal mechanism is same. Actually in memory, you can only store binary zero, means either store 0 or 1, this 2 bit. I hope you already know what is called binary numbers, right? So decimal to binary conversion and binary numbers, you already know this concept from your class 12 course, or maybe most probably these concepts have, I think, are also discussed in GE 103 course. So memory store, a computer memory store everything in form of binary. So whether it's a video file, audio file, or the text file, ultimately you have to convert it into a binary format. Ultimately you have to convert it to a sequence of zeros and ones, and that sequence only you store in memory. And there should be some mechanism that when we'll read those sequence of binaries, somehow we have to understand that, okay, this sequence is for text, this sequence is for video file and all. So all these are upper level of concept. Those are not important for this course, but what is important for this course is every data is stored in memory in form of binary. Okay, so if this point is clear, the next question is how we store binary information is memory, right? So how we store binary means how we store 0 and how we store 1. Suppose if you can invent a two mechanism. Mechanism 1, how you can store 0 in memory, and another mechanism is how you can store 1 in memory. Then that's done, right? You can just replicate these two mechanisms and you can store any sequence of binary. Suppose square means this is the mechanism how you can store is binary 0 in pen drive, and this is a mechanism using how you can store a 1 in your pen drive. Then if you want to store any concept, any data, you will just replicate this two module, right? And then you can store those information in memory. I hope it is clear. So now why I'm saying that I'm discussing it in upper level, because as I said, for memory there are different memory design, right? I said that RAM is a memory, hard disk is also memory, pen drive is also memory, then your memory card is also is a memory device. So there are many memory devices possible. So for each memory device, the technology or mechanism used to store 1 bit of information is different. If I go for RAM, then how to store 1 bit of information is different. If you go for hard disk, the mechanism to store the 1 bit of information is different. The only difference is here only, that how you are storing 1 bit of information, because every information is stored in memory in form of bits only, 0 and 1. Okay, let me check if there are any questions or not. Okay, no, there is no question. Actually, I'm teaching in full screen mode, and I'm checking your questions in a separate machine. So sometime it may be possible that I'll see the your comments or questions after some time. Okay, then let us start explain some non-technical concept again, and I hope whatever I'll discuss now will be known to you. Okay, so this is a diagram of a computer. This is a desktop computer, not laptop computer. So let us open this computer. If you open this computer, you will see this type of diagram, but this is a very old diagram. So I'll go for another diagram. This is the inside picture of a computer. If you open a desktop, you will see this type of diagram or this type of picture of a computer. Maybe some of you have experienced it, but I'm not sure, so I'm showing it here. This is the internal picture of a desktop computer. So here there is a big board. You can see here this big board is called motherboard. Okay, so inside this motherboard you can see there is a fan here, big fan. So inside this fan, below this fan, your processor will be there. So processor, that is called CPU according to the von Neumann architecture that I've explained. Your CPU will be here below this fan, CPU. And I have explained that some example of CPU is like Intel i7 or Intel i5. Those are recent processors, well-known processors. So okay, I'll come to this this part later again. And if you see, there are two slots here, right? These two slots are for inserting RAM. If you have RAM, then you can insert RAM in these two slots. These are the slots for inserting RAM. And you can see the outside of this motherboard, you can see there is a device here. This is your hard disk. So RAM you can store here, and if you want to store hard disk, you have to store it here. Hard disk will be stored here. Okay, now how can you relate this diagram with von Neumann architecture? I think it is very easy, right? When your desktop is not running, then all the datas are in hard disk, right? When you'll start the desktop, or you'll start not just desktop, it is true for laptop also, but I'm explaining here with a laptop, a desktop. So when you start the desktop, initially what will happen, the data that is stored in hard disk, one by one those data will go from hard disk to RAM, and from RAM it will go to CPU. Inside CPU also there are two types of memories, register and cache memory, that I will discuss after some time. But yes, first data is in a hard disk. From hard disk it will go to RAM. From RAM it will go to CPU. Inside CPU there are some more memories called cache memory. So it will go first to cache memory, and from cache memory it will go to core. Okay, so this is the sequence. Now if you want to purchase a desktop computer, there are two options, right? Either you will go for a branded desktop computer, like if you go for HP, IBM, if you can just simply order their desktop computers, and you no need to do anything. Just when your desktop computer will arrive, you can just install it and you can start working on it, right? But if there is an alternative option also, that you can go to a computer shop and you can assemble your computer, mainly desktop computer. Assemble means you can purchase the box, or you can say cabinet. This box normally you say cabinet. You can purchase the cabinet separately. You can purchase hard disk, motherboard, processor, everything you can purchase separately. This is also possible, and you can combine everything together to create a computer. So this is also possible, and many times we do this also. So in that case, when you go to a computer shop and you'll say, give me a processor, then the shopkeeper will give you either a Intel i7 processor, or Intel i5 processor, or a AMD processor, or maybe some other processor. But you can purchase a processor separately. So assume that this is your processor. So inside this processor, the main component or heart of your computer is this small chip that is here. It is not visible because it is placed means below this fan. If you remove this fan, then we can see the processor, which is there. So this small chip is the main component of your computer, which is called CPU, Central Processing Unit. So what is that? So maybe you have the term called multi-core computer, that this computer or this mobile has multiple cores, 8-core, quad-core, dual-core. It's all this term, I think you already know. So quad-core means there will be 4 cores, octa-core means there will be 8 core. All these things are actually internal to this small box, whatever you can say. And also the concept that I'm saying, cache memory and all, everything is the internal of this chip. So that's why CPU or the processor has the processing unit, that we normally call core, and then it has memories like called cache memories. So everything is inside this chip. When you purchase a CPU, this CPU from market separately as a chip, then you will purchase all the core, all the cache together at a time. That's why cache memory is called on-chip memory. Don't worry, we'll discuss all these things like cache, RAM, and all. These are the main component of this course. So throughout this semester, we'll again discuss everything. So if any point is not clear, and if you feel that cache memory is completely new for you, don't worry. This cache memory is the main component of this course. Maybe I'll spend at least 2 weeks, 3 weeks on cache memory. So it's today I'm just explaining and explaining the I'm giving you the brief overview. Okay. So what I was saying that if you purchase a chip, then you will purchase core and cache memory, everything you place in a single chip. That's why cache memory called as on-chip memory, because it is inside the chip. And this RAM, you can say RAM are placed outside the chip. Maybe they are placed in motherboard, but we are not considering motherboard as chip. The main chip is CPU. So CPU is separate, right? And we are placing RAM separately, and they are connected through some wires. That's why RAM is called off-chip memory. So maybe you need to remember this term, what is called on-chip memory, what is called off-chip memory. And hard disk is also kind of off-chip memory, but again, it's outside. So sometimes RAM is also called main memory, not the hard disk. Whenever you will you see this term written in textbook or written in any other place, main memory, you have to understand that we are trying to discuss the meaning of main memory is RAM, not hard disk. Hard disk is called secondary storage. Okay, so I think some basics are clear. So this is the back side of a computer. I hope you know this is the same computer. This is the back side, picture of back side. Here we can connect a monitor. These are the power cable. You can connect a power cable here. These are you can connect a serial. This is the serial port. So it is the old type of computer. Here you can connect your a printer, which is not required today. And you can see there are some USB port, and this is the audio connections, and this is for mouse. These are for mouse and keyboard. This device, this picture or this computer is also kind of old computer. It's not new, but I hope you are getting some idea about the internal logic of a computer. Not logic, but how internal layout of a computer. Okay, so now some more information about computer. Again, these are non-technical. So how this hard disk is connected with computer, you can see there are some bars here, right? These are called SATA. If you go even older version of computer, you'll see a big bus. Maybe if I go, you can see here in this diagram, you can see there is a fat bus like this, which is used at that time to communicate between hard disk and the motherboard here, but which is not required now. This SATA bus is this SATA concept is also old now. It is also not new. And you can see there is a device here. This device is actually CD-ROM, which is also almost obsolete. No one used nowadays, but we use pen drive directly. But yes, this is for CD drive. This CD drive is also connected with some bus through this motherboard. Okay. And in the motherboard, you can there are some more components you can see here. These are some slots here you can see. So in these slots, these slots are for using separate graphics processing unit. Like maybe you know what is called GPU. Maybe the technical details you don't know, but we'll discuss what is called GPU in this course. But these slots are mainly to install GPU or sound card or some other kind of graphics card, and all you can install it here in these slots. Okay, and you can see there is a battery here. This battery is called CMOS battery, and this is also this has a very important role. Maybe I'll discuss it after 2-3 slides, but you remember that there is a battery here. This is called CMOS battery. You can remove this battery also. And you can see there is a metal here. This metal is normally used for cooling. It is a cooling device. So to maintain the temperature in a room temperature in this chip or in this motherboard, these devices used normally. Okay, so this is how normally a computer looks. Okay. So now coming back to von Neumann architecture again. I hope now you can able to relate this von Neumann architecture with a modern computer. What is memory? What is central processing unit, input device, output device? I think most of the thing is now clear to you. Okay, now let us discuss more about memory. So there are different types of memory possible. So if you start from the bottom, tape storage. Tape storage nowadays is almost obsolete. Tape storage means the cassette, audio cassette or video cassette that we used in 90s, right? So those are called tape storage, tape devices. Now then disk means you can consider as hard disk, right? and then main memory. Main memory is a RAM, and after main memory there are cache and register. So this part, cache, and this part is inside the chip. As I said, that when you go and purchase a processor, this part is inside the chip. Cache, register, and CPU are inside the chip, and then outside the chip, main memory is placed, which is called RAM, is placed in motherboard, and even disk is outside the motherboard also. It is called Ssd. Right? So you can see speed is disk is the slowest memory, then RAM is the intermediate one, and the cache is the highest fastest memory device. Normally sometimes we don't consider register as a memory, but if you consider a register also as a memory, then register is the fastest memory, then cache memory, then main memory, then disk. And if you go in terms of cost, then register is the most costliest memory device, and disk is the most economical memory device. And that's why you can see when you will go to discuss about register memory will be very less. And even when we will discuss about main memory, RAM and hard disk, suppose you have a laptop or you have a desktop. So if your RAM size is 16 GB, or suppose if your RAM size is 8 GB, then your hard disk size may be 1 terabyte, right? 1000 GB. So why there is a huge difference? Why not we are using a 1000 GB of RAM? Because RAM is very costly. There are some other technical details also, but I'm ignoring all now. Today, for today's talk, you have to understand that RAM is expensive. You cannot purchase 1000 GB of RAM for a laptop, right? That's why RAM is expensive, but it is fast. So we use less size RAM, but a hard disk is slow, but it is less expensive. So use bigger size memory, bigger size main memory. Sorry, bigger size secondary memory like hard disk. Okay. So I think these are some examples. Can you guess what is this? Anyone? What is TLB? TLB I will not discuss today. Did I mention today TLB? Okay, it is written here TLB. Now see, TLB I cannot explain today. It's I will explain it maybe after 1 or 2 weeks. Today you will not understand. Maybe you will understand, but it will be completely out of context. After 2-3 weeks, I'll explain it. Okay, this is a example of RAM. If you go to a market now, any market, any computer shop, and say, give me a RAM, they will give you this device. You can simply purchase and take it to your home also. So it is the RAM, purchasing RAM for desktop means you will purchase this device. So there will be a separate lecture on this course to explain the internal mechanism of this RAM. But today I will not go more detail about it. Maybe in the initial 2-3 lectures only, before starting the textbook, I will explain you the internal detail of this memory, so that you will get some interest in this course. Okay, so this is a example of RAM. This is an example of hard disk. Okay, and I think this is an example of SSD. Okay, so what is SSD? I have not mentioned it yet. SSD is a device, also a special form of is a form of secondary memory, which is nowadays it is replacing the hard disk. So it's a better technology as compared to hard disk. So most of the modern computer, this SSD is replacing hard disk. So this is replacing with SSD, solid state device. So if time permits, at the end of this semester, I'll explain the internal mechanism of SSD also. But at this moment, you have to understand that SSD is a device, more advanced device, which is also used for store as a secondary memory, and which is replacing the hard disk in modern days. Okay, there is a question: why is cycle of memory are decreasing but speed is increasing? Okay. Why I'm thinking so much, because I don't know I should answer all this question today or not. Dilip, can you ask this question after 1 or 2 weeks? I'll answer you. Yes, there is. This is a concept called well-known concept called memory wall problem. But today I'm not explaining it, because I think I have not explained what is called cycles and all, right? And I have to consider everyone's interest, because today if I just suddenly start with cycles and all, maybe everyone will not understand. But please ask me this question after 2-3 weeks. I will explain you. And in fact, if at this moment, if you want to search more on it, you can search memory wall problem on internet. You'll know about it. Okay. So this is a hierarchy of what you can say memories. So I'll not discuss this slide in more detail. I hope I've explained you cache memory. I said cache memories are internal of a CPU, but I'll skip this slide because this slide is mainly explaining the internal structure of a cache, which is not important for today. As I said, there will be 2-3 weeks for explaining the cache structure. So let us skip this slide. Only understand that cache memory is inside the processor. Okay, chip design. So before going to chip design, I'll explain you some important point here. Important point is, I said, suppose if this is your CPU, I said inside CPU there are cache memory, right? Outside cache memory you have RAM, and then you have secondary memory like SSD or hard disk HDD. So initially your every data is in hard disk, right? And according to von Neumann architecture, whenever you want to do something, whenever you want to, suppose you have only two numbers, suppose you have 50 and 62 numbers, and you want to add these two numbers, that addition also you cannot do inside memory, because memory has no computation power. It cannot process anything, it cannot compare anything. It only task is to storing the data. So if you just want to store 50 and 60, means add 50 and 62 variables which are currently stored in memory, you have to fetch these 50 and 60 from hard disk to RAM first, and from RAM to cache, okay, and from cache to CPU, and the CPU will perform the addition, and then result will be again written back in this fashion. Okay, so the question here is, if eventually if the data is in your hard disk, and if I want to do some computation, then if I need to move the data from hard disk to CPU, then why this RAM and cache are there? What is the purpose of RAM and cache? And as I also mentioned that RAM is expensive, right? Cache memory is even more expensive. Then why we are using cache memory and main memory in between CPU and hard disk if the data is in hard disk, right? Because if you suppose your laptop is now powered off, it is not, it is off, and now if you start the laptop now, where is your initial data? When your laptop was off, where was your data? Your data was in hard disk, right? So when you are starting the computer, your data is moving from hard disk to RAM fast, then cache. Then why RAM? Hard disk, why hard disk is not enough? This is a question, right? So this is because most of the time it is found that these CPUs, so this CPUs, whenever the CPU will request for some is now in hard disk, then it has been found that the data that CPU is requesting, it is very likely that in near future the CPU will request for the same data. For example, suppose there is a data here called this data is I'm not saying it 50. Suppose this data is called D. Okay, so now if CPU is requesting for D now, then it is highly likely that in near future CPU will again request for D. So first time when CPU will request for the data will be not available in cache, it will be not available in RAM. So the request will go to hard disk, and from hard disk D will be first moved here. This is called fetching. First D will be fetched here in RAM, and then from here D will move here also, right? This is the first time. But as I said, that it is highly likely that in near future CPU will request this block again. So next time when you request, we will get the block in cache. And what is the advantage of cache? Cache is a very it's maybe expensive, but it is very fast in terms of SSD or in terms of hard disk, right? So if instead of going to RAM or hard disk, if you are getting the data in cache, then it will be very fast. So that's why if your data has a reuse property, then only cache and RAMs are giving advantage. And this is the main concept of your computer. Then most of the data that you are using has high chance that they are reusing. So this is the first concept that it says there are two parts of it. This is called principle of locality. Or for principle of locality, there are two parts. One is called temporal locality that I have just explained you. It's called temporal locality, that if the processor is requesting for a data, it is highly likely that the same data will be requested again in near future. This is called temporal locality. There is another concept called spatial locality. Spatial locality says if this core is requesting for a data now, suppose it is requesting for D now, it is highly likely that in near future it will request for the nearby data of D, Like in near future, maybe this core will request the data which is placed here or the data which is placed here, which are nearby of D. Okay, this is called spatial locality. That's why whenever a core request for a data, instead of sending these data, what we normally send, we send a chunk of data. Why you send a chunk of data? According to the spatial locality, because if it is requesting for this data, highly likely that in near future it will request for the adjacent data also. So instead of sending one data at a time, send a chunk of data, so that next time it will save time, because there will be heat in either cache or main memory. So that is called principle of locality, and it's two part: temporal locality and spatial locality. Maybe I'll explain again I'll explain this concept again when I'll explain the concept of cache memory and all. But maybe you can note it down, because I have in my slide this is not written, so you can note it down that principle of locality is an important point, and this is also important for your course. Okay, so let me delete all this thing if I have explained you what is called principle of locality. Okay, now I think one part is done. In one part, I've explained you that how computer works and how computer looks like. First, I've explained you the internal structure of a computer, internal structure of a desktop. Then I've explained you how a computer works. It's very upper level. There are I'll explain it in many levels. This is the most upper level. Then I'll go with the intermediate level, that how computer works. Then we'll go in the lowest level also, because this course is designed to explain how computer works in the lowest level. Okay, now the next question is how computer is designed. How computer looks like, that is fine. How computer works, that is fine. But how computer is designed? So computers are designed with chips. Like there will be, if you open a computer, if you open a laptop or mobile, there will be some chip, right? So this is an example of chip. But the next question is how we design a chip. So the lowest component to design a chip is this. It's called transistor, right? So I hope you know the behavior of a transistor. Like this will act as a switch. So if you supply some current through this, then this switch will be on. So these two can be connected. So this is called transistor. I'm not going more detail about transistor, but this is the smallest unit used to design a chip. I think this type of diagram is known to us, because from our digital logic course, we know that if we want to design a chip, we'll go with the AND gate, with some gate, and with using the gate, we'll either design a multiplexer, or we can design a flip-flop, and using those gates, using those small units, we can design a bigger chip. That we know. But these gates are actually logical components. These gates are actually designed with transistors. So this is you can see this figure. This is a figure of an AND gate designed with transistor. So gates are not the smallest physical components. Actually, the smallest physical component that is used to design a chip is called transistors. Okay, and how transistors are designed? Transistors are designed from the silicon. So I'll not go in more detail, because uh, this course is for computer architecture and not for chip design. So we have to draw a boundary that up to which point we should discuss. So in this course, we'll discuss less about chip design. We'll not discuss more about chip design, because some of you may not have the more internal knowledge about digital design. And if you know the internal knowledge of digital design, then also this course is mainly for how computer works and not how computer is designed, because internal VLSI design is not explaining the internal VLSI design is not the purpose of this course. So why I'm giving you the which level we'll discuss. Let me give an example. Suppose I say that computer can perform addition. So what we will do, we'll say that suppose this is a module, and in this module can perform addition. So we'll supply A and B here, and this module can perform addition. So result will will find result here. And suppose this module can perform both addition and subtraction and multiplication. Suppose, so there will be some lines here through which will command this device that okay, I have given you two input A and B, you perform addition or you perform multiplication, right? So we'll most of the time we'll try to explain it in this way. Why? Because I'll go less in digital design, because this type of design you know already from digital design course. And yes, there is some, it's not like that I can completely ignore it, but I'll try to discuss less on it. But yes, the some concept of gate, some concept of multiplexer will be required. So here is an advice that maybe I'll not explain it more detail, but these few things will be required. One is the knowledge of gate. So if you don't have knowledge on digital design, try to clear the concept of gates. Just the first chapter of Maurice Menabo, concept of gate, and then at least you should know what is called multiplexer, decoder. These few the basic component, these will be required. Without knowing the basics of multiplexer, it will be difficult to understand the concept of computer architecture also. But yes, I'll try to go less deeper on VLSI side. This is a well-known diagram we use. So what this diagram is saying that, as I said, the main components of the are transistor to design a chip. So this diagram is saying this is called Moore's law. So according to this Moore's law, that every year or the number of transistor that you can place in a chip is becoming double in every 2 years. So suppose if this is your chip area, physical chip area, then suppose this year you can place 2000 transistor in this chip, then after 2 years you can able to place 4000 transistor in this same chip. So this is called Moore's law, and that's why the chip design and this area is becoming complex, but it is also becoming cheaper. So if you see a hard disk 30 years back, or if you see a computer 30 years back, it was huge in size, and now you can imagine this compare the size of today's computer, or it's a very small size, right? So you can see the difference, and this difference is mainly because of Moore's law, that how much transistor you can place in a fixed area, chip area, and that is decreasing. So or we can say density is increasing. Okay. This is called Moore's law. Now, let us again start with basics of computer, but this time we'll not go with real figure. So what I have explained till now, a computer has four parts, right? CPU, memory, and input output. That I have explained you. CPU, memory, and input output. This is according to von Neumann architecture. Also, I have explained you. So third is interconnect. Interconnect means the wires and all, though using which these modules like CPU, memory, and all are connected. So this is also a main component of a computer. So any computer, these are the major components like CPU, memory, input outputs, and interconnect. I hope you can relate this, that some examples of CPU I have given. This is called processor. Memory example I've also given. Input output means keyboard, mouse, monitor. These are input output devices. Interconnect is not visible from outside, but the example that I've given you, that bus and the bus, the SATA bus that is connecting the hard disk and motherboard, these are also, you can say, interconnects, but interconnects are also possible inside the chip. So those I'm not discussing today. Okay. So now from this, if we go more inside the CPU, then CPU has registers, arithmetic logic unit, control unit, and some internal CPU interconnects. So registers are very fast memory that I've mentioned. I think that a register is above the cache memory. So every CPU there are registers, but limited number of registers. So those registers we normally use to store information before processing any operation in a CPU. Suppose the CPU wants to perform addition. So addition of two numbers, then these two numbers first they will fetch from memory and store in two register first, and then this CPU will perform the addition. I'll discuss this in more detail in next slide, but at least you should know what is called register. It's a very fast memory stored in CPU. Okay. Then arithmetic logic unit, this is the main unit of CPU. Arithmetic logic unit performs all the arithmetic operation like addition, subtraction, multiplication, division. All the operation are performed in this arithmetic logic unit. So I'll discuss arithmetic logic unit in more detail. Control unit is to control all the devices, because CPU is a very big device. Though it looks like small, it's a very complex device. So there are a lot of things that there are internal mechanisms. So to control everything, there is a unit called control unit. And internal CPU interconnects. Internal CPU interconnects are again, you can consider as wires, which is connecting different components inside the CPU. So all these things are called CPU. This is called CPU. So I'll spend few weeks to explain you CPU. So maybe you can understand that why it is not possible to explain everything in this class, because we will spend at least 4 weeks to explain the internal concept of CPU, that how CPU executes your commands. Okay. So now memory, cache memory, main memory, secondary memory. I think you can relate with example what is called cache memory. Main memory are, as I said, these are called RAM. Secondary memory means hard disks, SSDs already, etc. So here also in cache memory only, I will explain. I'll spend 3-4 weeks at least 3 weeks in cache memory, and then main memory and secondary memory also I'll explain. After all this thing, I'll also explain what are the recent advancement going on in CPU part, what are the recent advancement going on memory part. All these things also I'll explain. Okay. But I think this is clear. This is clear because cache memory is normally, though it's a memory, but it's a part of CPU, not the other memories. So that's why normally cache memory is considered as on-chip memory, not off-chip memory. And I think I already mentioned that when you purchase a processor, your cache memory is inside that processor. But that is not true for RAM, right? RAM is a separate chip. Okay. So now operation of a computer. Well, yes, I have, I think, 10 minutes, so I'll explain this slide also. Operation of a computer. So as I said, that in computer, if you want to execute something, you have to give some sequence of commands. Okay, maybe I'll wait if you have any questions, because otherwise, if I stop exactly at 55, then I'll not have any time to answer your questions. So I think I have to stop at 2:55. So it is already 2:51. So I'll stop here. I'm waiting for your questions. If you have any question, you can ask. So if why I'm not starting from the next slide, because if I start from next slide, then at least I need at least 30-40 more minutes to explain that next concept that I want to explain. So that's why I'll start it on next week. So what I'm doing now, you can see that whatever I'm explaining, maybe I'm not following the textbook, but I'll continue this same way, I think, in at least next two lectures also. So initially in this 2-3 lectures, what I'm trying to explain, the basic architecture of computer, how, and not in less technical manner, I'm trying to explain you how computer works. And within these 2-3 lectures, I'll give you a bigger picture, like from the upper level, that how computer looks like, how computer works, and then we'll go one by one to each component and understand, and at that time we'll follow the textbook. But till now, when I'm not directly following the textbook, you have to listen my lecture properly, and if any of this component or any of this concept that I'm saying it is interesting and you want to explore it more, you can search it on internet. And if you have some queries, you can always ask. There are some questions that has been asked in why I'm not asking all questions here, because one by one I'll answer those questions, and some to answer some questions we need some concepts. Those concepts are not yet discussed here. That's why I'm ignoring those concepts. Okay, so I'm stopping here. I don't think you have any questions. So that's it from this class. Thank you. We'll meet next week.